Imagine waking up, walking outside to your bike, and having absolutely zero memory of how to ride the thing. You don't know how to pedal, you can't balance, and steering? Forget about it. You'd have to figure it all out from scratch, probably bruising your knees all over again every single day. Sounds completely exhausting, right? Well, surprisingly, this state of total amnesia is exactly how standard reinforcement learning trains AI agents. They basically treat every single task as an isolated episode, which forces the AI to start from a blank slate instead of actually building on past successes. But today, we're looking at a framework that changes all of that. Welcome to today's Explainer. We are unpacking a pretty groundbreaking new framework called Skill1. This research proposes an incredibly elegant solution to that whole AI amnesia problem by giving agents a unified, evolving memory. It's a real game changer for how language models learn to interact with complex environments. Okay, let's dive into this. The foundational concept here is what the researchers call a persistent skill library. See, instead of just hoping an AI vaguely internalizes good behaviors into its billions of hidden parameters, this system gives the agent a literal, explicit bank of past successful strategies. It's like a permanent cheat sheet. If it figures out a clever way to solve a problem today, it writes that strategy down in its library. That way, it can just pull it right off the shelf and reuse it tomorrow. Here's our roadmap for today. We'll quickly cover the AI amnesia problem, then look at the three-stage life cycle. After that, we'll talk about the three-headed monster flaw in prior methods, introduce Skill1, break down the math behind the shared signal, and finally wrap up with the results and future implications. All right, let's kick things off with Section 1, the AI amnesia problem, treating tasks as isolated episodes. So, in standard reinforcement learning, strategies that lead to success are basically absorbed implicitly. They just become these really subtle tweaks to the model's overall weights. The agent can't explicitly say to itself, I remember this exact trick I used yesterday. Let me just apply that here. Without a persistent library, it fundamentally struggles to reuse specific, targeted strategies on new tasks. Moving right along to Section 2, the three-stage life cycle, how to maintain a skill library. Dealing with the memory bank breaks down into a highly logical workflow. For an agent to actually use its library, it has to master three distinct capabilities. First up is selection. It has to hunt down the right skill for the job. Second is utilization. It needs to actually execute the task using that specific skill. And third is distillation. After the task is done, it has to reflect on what just happened and derive a brand new reusable skill to add back into the library. Which brings us to Section 3. The three-headed monster, the flaw of prior methods. You know, older methods had this huge issue where we could essentially think of them as a three-headed monster. Researchers used to optimize selection, utilization, and distillation in total isolation. And worse, they'd use different conflicting reward sources. So one stage might get a thumbs up from a human teacher, another from some heuristic score, and the third from the actual task outcome. Because these three capabilities really have to work together, optimizing them with inconsistent signals literally pulled the agent in different conflicting directions. Let's put this into perspective. Leaving just one of these capabilities unoptimized creates a massive bottleneck. I mean, you could have a policy that is an absolute genius at executing a skill. We're talking perfect utilization. But if its selection capability is terrible, and it constantly routes to the wrong skill for the job, the whole system fails. They are completely 100% codependent. And that leads us to the solution in Section 4, introducing Skill1, unified evolution. Skill1 completely removes that conflicting three-headed monster approach. It takes our agent and connects it seamlessly to its library using just a single policy. Instead of farming out tasks to external, frozen modules, Skill1 trains one single policy to handle query generation, ranking, interacting with the environment, and distilling new skills. It is the whole shebang, an all-in-one unified system. There's a great quote from the researchers that really nails this. It says, Skill1 trains a single policy to co-evolve skill selection, utilization, and distillation toward a shared task outcome objective. That is the absolutely crucial point here. Everything in the Skill1 framework now revolves around one unified shared goal. By linking all three stages to the exact same objective, they can co-evolve naturally without stepping on each other's toes. Let's get into the mechanics in Section 5, the shared signal, visualizing the math. The anchor of this entire system is the task outcome signal, represented mathematically as R of tau. Now, don't let the math scare you. It's just a binary measure. Did the agent succeed or fail at the task? Yes or no? This directly serves as the reward for the utilization stage. If the agent executes well and succeeds, utilization gets a reward. But here is the genuinely genius part.
how they decompose this one single signal to train the other two stages.
Let's look at how this builds for the selection stage. The researchers isolate what they call the low-frequency trend of the outcome signal. Think of this as the moving average of success rates when a specific skill is used. By tracking this overarching trend, the system can see the consistent, long-term utility of a skill. It uses this low-frequency trend to explicitly credit and train the selection capability, pushing the agent to choose skills that consistently get the job done. Meanwhile, the distillation stage gets credited using the high-frequency variation. This is for those glowing light bulb moments of pure discovery. High-frequency variation is basically the deviation of the current outcome from that moving average trend we just talked about. It asks, did this newly distilled skill suddenly spike our success rate way above the norm? Did it push the boundary? If it does, it highly rewards the distillation capability for creating a genuinely useful, novel strategy. So it's one single signal elegantly split three ways. All right, let's look at the hard data in Section 6, Results and Future, Proving the Unified Approach. 97.5%. Let that sink in. That is the massive success rate the Skill-1 framework achieved on ALFWorld. If you're not familiar, ALFWorld is a really tough standard benchmark where an AI has to complete highly complex, multi-step household tasks using nothing but text. Hitting 97.5% fundamentally crushes prior skill-based and reinforcement learning baselines. It's not even close. And Skill1 didn't just dominate on ALFWorld, it actually surpassed baselines on the WebShop environment as well. The training dynamics confirmed that selection precision, utilization success, and library quality literally all co-evolved simultaneously. Actually, perhaps the most interesting part was the ablation studies. They proved their core theory. If you remove the mathematical credit signal for just one of those stages, the entire evolution degrades. They are truly mutually dependent. You pull one out and the whole house of cards tumbles. Which leaves us with this final thought. If standard AI is like waking up with amnesia every day, Skill AI is like an agent that not only remembers how to ride a bike, but can automatically write its own physics textbook, select the absolute perfect gear for any terrain, and invent brand new biking techniques on the fly. As these models move from isolated little episodes to continuously evolving, self-refining memory systems, we have to ask, what are the broader implications for truly autonomous, lifelong learning AI? It's a fascinating leap forward and one that fundamentally changes the trajectory of how agents behave. Thanks so much for joining me on this explainer, and keep questioning what's possible.